with me going on here? Not much right on this one. Section 2.3, day 2. Wait, so here we go. If a 0 occurs twice, we say it has a multiplicity. That's a new word here for us. Multiplicity of 2. So I'm going to give you a minute to get a head start on the writing here, and then we're going to talk about it. And this bottom thing is pretty much what we wrote out yesterday, but I wrote it again because it's very important. In the past, we've called this 0 a double root or a repeated 0. We've said that. But the technical term to say this is multiplicity. There's a movie made about 1992 called Multiplicity about a man cloning himself. It's not that good of a movie, but we'll look it up. Next, the Precalculus thing. So, I think of the guy that says it. Something. It's not good that good of a movie, but. But he clones himself and he can do all the stuff he used to do, but his clones keep getting dumber and dumber, and every clone that he makes is a dumber version of himself. So by the end, it's just bubbling and getting more through. That's the movie in a nutshell. A couple important things to notice about this. If you have any factor to the k power, if k is bigger than 1, then we say that it has a repeated 0, right? And then in the past, we talked about a double 0. But whatever that power is, we say is a multiplicity. So if it's to the 3rd power, we say it has a multiplicity of 3. If it's to the 7th power, we would say it has a multiplicity of 7. Basically, that means it repeats itself that many times. And a would be the 0 that occurs at. Notice the power has to be bigger than 1. So if it's to the 1st power, there's no multiplicity. It doesn't repeat itself. It's just a normal 0. And then we talked about this yesterday, still really important when we're graphing. If your power is odd, remember that the graph at that 0 will always cross the x-axis. And if k is an even number, like x squared or x to the 4th, then it will just touch the x-axis at that 0 and not cross it. Very helpful when we're graphing these today. But what I want to do first, after you get this written down, is I want to show you what this looks like on the graphing calculator. What does a repeated 0 do? Or how does a multiplicity of 2 differ from a multiplicity of 4? And so what we're going to do is we're going to graph on the calculator, and if you're welcome to sketch it on your paper, or if you just want to write what happens on your paper. But I'm going to graph these two on the graphing calculator. And so we can see what happens here. Some of your homework today, you're going to have to give the 0 and the multiplicity and say whether it touches or crosses, so we could kind of do that with these two here before I graph them. Y equals x minus 1 squared, what would the 0 of that function be? Positive 1, right? Right, because the 0 would be, we said this equal to 0. X minus 1 equals 0. So the 0 is 1, right? We did that yesterday on our homework, 18 and 21. Would we say this has a multiplicity? The multiplicity is if the exponent's bigger than 1, we would say this has a multiplicity of 2. And would it touch or cross the x-axis at that point? Because it's even, it touches the x-axis, not crosses. If you look at this function, it's very similar except for one thing, the multiplicity. It also has a 0 at 1. Because it's even, do you agree it also just touches at that point? But its multiplicity is 4. So in algebra 2, we would say this has a double root. So going the same lines, you could think about this has a quadruple root, right? Meaning that it counts like as 4 zeros. Yes, Maddie?
So to determine the multiplicity, you just look at the power?
Always, yes.
So it's whatever the power is.
Yeah. And it's because you can think about this is really this, right? X minus 1 times x minus 1. So it counts 2 times. So we say like it has a repeated 0 because it's 2 times, or the power is 2. So that's why it's a multiplicity of 2. But yes, it's always just the power. And so that's why this one has a power of 4. It has a multiplicity of 4, because there's really 4 of them there. All right, so I'm going to go to the graphing calculator, and I already have them programmed in here. Maybe, if my calculator works. I'm sure it's not going to. So I'm going to hit graph, and I'm going to see if it'll graph them for us again. If it's already graphed, I'll regraph it. So it's going to graph the squared one first, and then the fourth one. So there's x squared. There's x to the fourth. Kind of hard to see what's happening at the zeros. Just like the one we did on our homework today, you can see that this goes up pretty quickly. But I want to look at what's happening at 1 on the multiplicity. So I'm going to zoom in here. And I'm just going to move my little flashing dot over here, close to 1, maybe. And I'm going to do it again. It's going to retrace it. Watch x squared, and then watch x to the fourth. There's x squared, multiplicity of 2. There's x to the fourth, multiplicity of 4. What's happening with the higher the multiplicity? Can you see anything there? I'm going to zoom in again. Yeah, it seems like it's touching the x-axis for a longer time. I like to say it's flattening out. The higher the multiplicity, the more that your graph flattens out on the x-axis. So like x squared comes down, and it's a double root, so it kind of hangs there a little bit. And then x to the fourth hangs out even more. If I did x to the 6th, which I can go back and do really quick, not just x to the 6th, but if I did the same graph and I added x minus 1 to the 6th, it's going to stay there even longer, right? You see how that comes down and flattens out even more. And so when you're graphing these by hand, I'm very lenient on it, but I want you to be aware that the higher the multiplicity, the more that it flattens out there. So even ones are always going to look like parabola shapes where they just touch, but they're going to flatten out the bigger the multiplicity. For an odd multiplicity, let's look at one of those so you can kind of see how it flattens out. Let's do the same thing, only no multiplicity would just be like x minus 1. Right? If there's no power, that means it doesn't do anything weird. It just goes straight through the x-axis like we've always done. So what if I did x minus 1 to the 3rd power and had a multiplicity of 3? Watch what happens at that same 0. So there's no multiplicity. It just goes straight through. But then there's a multiplicity of 3. And for me, I always think about x cubed. X cubed has that little turn I call it S graph. And that's what happens here, right? It like comes down and it kind of like hangs out there on the x-axis a little bit. It only has 1 0, but it flattens out. If you had a multiplicity of 5, guess what's going to happen? It's going to be even flatter. And so, like I said, I'm very lenient on the graphing of these because it's kind of weird to do it by hand sometimes. But I'm looking for some effort there that it kind of makes a little dip when it crosses the x-axis. Does that make a little sense? Multiplicity kind of makes those little curves on the graph. So that's going to come into play today when we graph these. All right. So let's graph. Oh no. This is what your homework says today. It says, and this is very similar to the test question, it says state the degree and list the zeros. State the multiplicity of each 0 and if it crosses or just touches, and then sketch the graph by hand. And so we're going to do all of those things. It's up to you if you want to write all those directions down. So we're going to start here with this lovely graph. There's really only 2 that you have to graph by hand on your homework today. Some you're going to match up. But on your test for this chapter, definitely you're going to be graphing by hand, and those questions are probably worth like 10 points apiece. So kind of a big deal. And I kind of have some steps. You don't necessarily have to do these steps in this order, but when you're graphing these functions by hand, these are my steps that I recommend doing. The first step that I think you should do is when you find the degree, you should do that test that we did yesterday. Like, how does the end behavior going to look on this graph? Because that helps me when I'm graphing it. So just like yesterday, looking at this, can you tell me what the degree of this function would be? Degree 4, because x to the third times x is x to the fourth. We could say that this is degree 4. Which means an even degree, my arrows are both going to go the same way. They're either both going to go up or both going to go down. What's it going to be in this one? Yeah, because that's a negative there, that would be negative x to the fourth. They're both going to be pointing down. It does not say in the directions that I have to do the whole as x approaches infinity, blah, blah, blah. But it's nice to know that. So for me, when I do this problem, I would just draw like 2 arrows down like this, because it reminds me to check my graph to make sure when my graph is done, both arrows better be pointing down or I've done something wrong. Find the zeros, and they say that in the directions here, so we have to do that anyway. But if it's factored, which it's going to be for us, or it's going to be easily factorable, we should be able to find the zeros very easily, and we should be able to say the multiplicity and whether it touches or crosses, which helps us when we're graphing. And remember to find your zeros, you just set each one of these equal to 0. So if I set negative x cubed equal to 0 and x minus 2 equal to 0, I'm fine with you showing that work or not showing it. Right? That's just going to be 0. And this one's going to be 2. Anyone have a question on where I'm getting those zeros from? Yes. Just because you have to think about the degree is the highest exponent, but if it's factored out, you have to multiply, right? So like, if I multiplied this out, it would be negative x to the fourth minus, or plus 2x cubed. But you got to think about what would be the highest x if you multiplied it out. So if you just go through and multiply all the x's together, you would get the highest degree. Does that make sense? Multiplicity. Does this 0 have a multiplicity? Negative x cubed. What would the multiplicity be? 3. The exponent is the multiplicity. So this has a multiplicity of 3. And because that multiplicity is 3 and is an odd number, is it going to cross or touch the x-axis at that point? It's going to cross. Odd crosses. Bryce. 0 of 2, the 0 at 2, does it have multiplicity? What's the power out here? 1. So we don't say multiplicity of 1, because when you multiply by 1, nothing happens. So it has no multiplicity. So I'm okay if you just write nothing, or if you want to write something, you can say no multiplicity. But do not say a multiplicity of 1, because that's not correct to say. Is it going to cross or touch? Because 1 is an odd number still, so it's also going to cross. That's doing all the directions that it says for me to do. What are my other suggested steps here after we find the zeros? Y-intercept, you don't always have to find the y-intercept, but it's like a free point. I think there were 1 or 2 on your, on the homework. I think number 6, I didn't even follow the directions, but it said to find the y-intercept. Y-intercept is like a free point on your graph, because to find the y-intercept, all you do is plug in 0 for x. And so usually, if you plug in 0 for x, you can get the answer like pretty easily. I just usually make that into an xy chart, because I might have to fix other points too. So if I'm going to find the y-intercept, I'm going to plug in 0 for x. And what am I going to get when I plug in 0 for x into this problem? I'm going to get 0 times negative 2, which is just 0. Do you agree with that? So the idea is it's like a free point. Sometimes your x-intercept might be like 77. Maybe you don't want to graph that. But 0, 0 is not a bad one to graph. So that's kind of maybe you want to do the y-intercept. And then step 4 is after we graph this, which we're about to do, you might have to pick some points in between. And that's the part that we're trying to avoid having to make a giant xy chart. And in number 2, when you first graph these, you pick like 8 points at least. We don't want to do that anymore. So all this other stuff is supposed to help us. So do you see that graph? Do you see the grid behind it, how light it is now? Can you even see that, or it just looks like white to you? There's like little blue lines here. This is the same graph I've always used, but my smartboard had an update, and this is now what it looks like, thanks to my update. Very angry. Because now you can't even see my little lines. So let's graph what we know. We know there's a point at 0, 0. That's a free point. We know 2 zeros. Oh, look, we already knew that. X equals 0. That's a 0. And x equals 2. So that kind of stinks because our y-intercept is also our 0. We know both of these zeros cross. And we also know that both arrows should be pointing down. So I'm not going to actually draw this in yet, but both of these arrows have to point down. So do you agree that from here and here, both of them should be going down? And since it crosses, do you agree that when I pick a point in between, it better be up here somewhere? Otherwise, it's not going to be crossing. So that stuff is going to kind of help us here. What do you think would be a good point to pick on our XY chart here? You got to pick points in between your zeros to see what's happening. So if we pick 1 here, you can use your calculator, but you're going to get negative 1 times 1 minus 2 is negative 1. I think we're just going to get 1, 1. Oh my gosh, I'm so frustrated with my little graph here. Now here's where the multiplicity can help you. We're going to actually pick some more points since this is our first one that we're doing. But this is where I use multiplicity, because if I was doing this on my homework, I wouldn't pick any more points, because at 2, there's no multiplicity, right? So if there's no multiplicity, that means it just goes straight through. Nothing crazy going on. But at 0, we have a multiplicity of 3, which means this cannot just go straight through. You got to do some kind of little wiggly thing there. Right? So that's where multiplicity can help you. But let's actually pick the points and see what happens. Let's pick the point on either side. So let's pick negative 1, and let's pick, what would that be? 3? 1, 2, 3. Just so you can see, this is not a perfect little parabola, because one side has a multiplicity and one side doesn't. And again, you can use your calculator, but negative 1 to the third is negative 1. But then that negative in front is going to make that positive 1. And negative 1 minus 2 is negative 3. So 1 times negative 3, I think, is negative 3. If I go on the other side where there's no multiplicity, look what happens when I plug 3 in there. 3 to the third is 27, but that negative in front makes negative 27. 3 minus 2 is 1. So that's negative 27. I'm not going to graph negative 27. But that means on this side, it's going to go down like pretty quickly. So on this side, I'm going to make it go pretty much straight down. Not quite. I kind of went a little crazy there. But on this side, I need to kind of show that it has that multiplicity of 3. So I always think about the way x cubed looks, like that little S shape. So let's see if I can do this on the first try. Connecting these 2 points here. Yes, no, you see how that kind of dips in? And again, I'm very lenient when I'm grading these. I'm just looking for effort there, that you know there's a multiplicity. Sometimes people like to draw me a little arrow and say, multiplicity here. But I'm really just looking that your graph dips in somewhere. But there's a difference between those 2 zeros. One has a multiplicity, one doesn't. How do you feel about that? Overjoyed. Let's do another one. Find the zeros, state the degree, crosses, multiplicity, all that fun jazz. You can't, they're disposable, so they're not letting it from its own mind. Precalculus in the test. What's the degree of this? If you multiply this out, it would be x to the third, right? If you multiply this out, it would be x squared. So when you put that together, that would be 35. You with me on that? Odd degree means our arrow should be going in opposite directions. Because it's a positive leading coefficient, that means positive side goes up, negative side goes down. So again, you don't have to do this, but I feel like it's helpful to me to remind myself my graph better look like that when I'm done. Just like my last graph, both arrows had to go down. What else we want to do are zeros. So this would have a 0 at 1 and at negative 2. That has a 3 out there, so that means it has a multiplicity of 3. And because it's odd, it crosses. This one in 2, so that means it has a multiplicity of 2. And because it's even, it touches. Anyone have a question of where you're getting those values from? Every time you should be looking at your degree, your in behavior, your zeros, multiplicity, cross or touch. The other thing that was on my list was the y-intercept, which we could go back to later, but let's just go ahead and do that now before I start graphing. My y-intercept is what do I get when I plug 0 in there, and again, usually it's supposed to be an easy number to get. So if I plug 0 in here, I get negative 1 to the third, which is negative 1, and 2 squared is 4, so that means 0, negative 4 is also on my graph. So I know my in behavior, I know my zeros and how they act, and I know my y-intercept. So when I graph that, 1, 2, 3, 4, I have a 0 at 1 and a 0 at negative 2. I also know my in behavior. I know that this one has to go up. So this arrow has to go up from here. This one has to go down from here. I also know my multiplicity. This one has a multiplicity of 3, so I should do some kind of cute little x cubed squiggle there. This one is 2, which means it only touches. So I don't know exactly how it comes up, but it's better come up and come back down from there, right? So that's something that you want to think about before you start just randomly connecting lines. But I think we need to pick at least one point, and what would be that point we need to pick? You've got to pick in between your zeros, because how do you know if it comes straight up? Maybe it goes all the way down here before it comes up, so you got to pick in between your zeros. At minimum, you got to pick that. If you want to pick numbers on the other side, you can, but the idea is your in behavior helps you, and you don't have to do that. I plug negative 1 in there, I get negative 1 minus 1 is negative 2 to the third, which would be negative 8. And negative 1 plus 2 is just 1 squared, which is 1. So at negative 1, it actually goes all the way down here to negative 8. 3, 4, 5, 6, 7, 8. Which means it actually goes down here before it comes back up. And that's all the points I'm going to pick, and I'm going to be able to make a pretty accurate graph using my multiplicity and my in behavior to help me. So since this one has a multiplicity of 2, I know that it's going to come down here, it's going to turn back up, and it's going to touch and go back down. So I'm just going to kind of go with that. It's going to come down here, it's going to come up. That's really terrible, but you know. It's much harder to graph on here than you think. Alright, I'm going to fix this side. This was down here at 1, 2, 3, 4. And then this is going to come back up through here, but do not just go straight through this line, right? It had a multiplicity of 3, so you want to make sure that you kind of make it turn a little bit. So when I connect these, see, look, that's all I have to do to show that, hey, I know there's a multiplicity there. I kind of made it do that little S sort of thing there on that. Right? Is that a perfect graph? No. Is it a pretty accurate graph for not picking that many points and just using what I know? Yeah, that's pretty accurate. Questions about that? 2 of those on your homework today. Definitely those on your test, doing the same stuff. The other thing is easy compared to all this graphing stuff. Going backwards, if they give you the zeros, they want you to be able to write the function. We're going to do this tomorrow, so I switched the order here. This is our last one. Something that you did in Algebra 2 last year as well. But it's important that you're able to find a polynomial function. It makes me laugh that the directions say, using only algebra, find a cubic function with the given zeros. I don't know what else you would use. Using magic, find a function. Without using the back of the book, find a function. The big thing I want to emphasize from this is I want a function, which means you better have an equal sign, and I want you to work it out and actually give me like the polynomial, not the factors. But if they give you these zeros, think about it, it's like the zeros. It's like saying there's a 0 at 3, there's a 0 at -4, and there's a 0 at 6. And the big thing that you just have to remember is how do you go back from one to the other? So if this is the 0, what's the factor? X minus 3, right? If that was the factor, that would be the 0. So if -4 is the 0, the factor is +4. And if 6 is the 0, then it's x minus 6. That's the easy part, right? So this is a function, so you have to either tell me y equals or f of x equals. If not, you haven't made a function here. So I'm partial to the f of x, but you could say y equals. And then the only other thing is I want you to just work it out. FOIL it out and give me at that cubic function, which is just some good old fun. You can't FOIL 3 things at once. You have to do 2 at a time. So like you would multiply these 2 first. So I would get x squared plus 4x minus 3x would be plus x minus 12. And then you have to take that times x minus 6. And then just remember, this is not foiling. That's why I don't like foiling, because it only works with binomials. But you have to multiply everything in the first times everything in the second, which means I think you should have 6 things. What are you done with all that? So that would be x cubed minus 6x squared plus x squared minus 6x minus 12x plus 72. And just put like terms together. Negative 6x squared plus 1x squared would be minus 5x squared. Negative 6x minus 12x is minus 18x plus 72. That would be the cubic function with those zeros. Yes. You got to take this x times both of these, right? So this x squared goes to both of these. Now this x goes to both of these. X times x is x squared. X times negative 6 is negative 6x. And then the 12 goes over there. So everything in the first times everything in the second. Does that make sense? Okay. So your homework is, there's a couple that are on your graphing calculator that you can't do yet. So let's make sure we read those here before we run away here. This is day 2, 9, 12, which I think, I don't know which ones are graphing. Maybe those. No, not 9, 12. 39 through 54, multiples of 3, 55, and 71 through 73. 45, 48, and 51, we will be using the graphic calculators, and so don't do those yet. Leave a spot in your homework if you want, or just wait and we'll do them at the end of your homework tomorrow. Or if you get super excited, you can look them up tonight on your own graphing calculator if you have the app on your phone, or you look one up on the computer, but just wait till tomorrow. I'm fine with that. But don't do those yet, 45, 48, 51. But what are the ones that you should be graphing here? Oh yeah, 39 and 42. 39 and 42 are the two that you should be graphing that are just like the ones we did. It says state the degree, what's the multiplicity, sketch the function by hand. So there's only 2 that you're graphing by hand, the rest are either matching or just, finding zeros. And then 3 of those you're doing tomorrow. 39 and 42 you're graphing. And just sketch those by hand. I think 42 has a pretty big number on it that we'll kind of talk about tomorrow. If someone have a question. So tomorrow we'll finish up these 3 problems on our graphing calculator, and then I also have a graphing worksheet for you tomorrow. More graphing by hand tomorrow as well. So that's the plan for tomorrow.